Welcome to Electric Circuits Lesson 4. Up to now, we have assumed that the battery is giving out the maximum power that it can. But a battery has its own resistance. So, the battery has a maximum amount of volts that it can give, which we call now the EMF. But it cannot always give that maximum amount of volts because the battery has its own little amount of resistance that takes energy to push the electrons through that resistance. So, the battery loses some of this EMF value because of the battery's internal resistance. So the symbol for internal resistance is now small r. And that is the little resistor inside the battery that takes some of its energy away and lowers the EMF. Therefore, we have a new equation for you to remember. EMF has got this little E value symbol, which is then V plus I times small r. Okay. Example. Determine the internal resistance of a battery that has an EMF of 12 volts and has a potential difference across the terminals of 10 volts when a current of 4 amperes is flowing through the battery when connected in a circuit. So, they give you EMF is 12 volts. The volts in the circuit is 10 volts and the current is 4 amperes. So let's use our new equation. The EMK, the volts and the current we have. It's given in the question. They are asking the internal resistance of the battery, which is small r. So let's substitute the values. EMF is 12 volts plus the total volts, which is 10 plus the current, which is 4 amperes. So now you have to rearrange your numbers to get 12 volts minus 10 volts divided by 4 amperes. That gives you 2 volts divided by 4 amperes, which is 0.5 ohms, small r. Example 2. In the circuit represented below, two 6 ohm resistors connected in parallel are connected in series with a 25 ohm resistor. The battery has a EMF of 12 volts and an internal resistance of 1.5 ohms. Calculate the equivalent resistance of the parallel combination, therefore RP. So let's just focus on the first question first. We want RP. So 1 over RP is then 1 over R1 plus 1 over R2. So 1 over R parallel is then 60 ohms and 60 ohms there. You are substituting the 6 ohms resistor here and the 6 ohm resistor there for R1 and R2. Now you need to add them together to get 2 over 60. But we want R parallel, not 1 over R parallel. Therefore, we need to switch our fractions to get 60 divided by 2, which then gives you RP equal to 30 ohms. Now let's look at the second part of the question. Total current in the circuit. That means the current that flows here through that 2.5 ohm resistor before it splits up there. So, if you go to Ohm's law, it's R equal to V over I. But we need the total resistance. We've just calculated the resistance in parallel, but we also need the resistance in series, which is 25 ohm, and also the internal resistance, which is 1.5 ohm. Don't forget that little one. So, the total resistance is then the external resistance, which is these, plus the internal resistance, that little one of the battery. And the external resistance would then be the resistance in series plus the resistance in parallel. So, if we want the total resistance, the resistance in series is 25 ohms. The resistance in parallel, we just calculated to be 30 ohms, plus the internal resistance, given in the question, 1.5 ohms. So that gives you 56.5 ohms. Now we can get back to the final question. R is V over I. The total resistance we just calculated to be 56.5 ohms. The volts is 12 volts. And then you can calculate I, which is 12 over 56.5 ohms, which gives you the total current flowing through the circuit is 0.21 amperes. Let's look at the last part of the question. Potential difference across the parallel resistors. So, RP is VP over IP. Remember to use the correct values together. The resistance in parallel we calculated to be 30 ohms. We want the potential difference, and we know that the current going in there is 0.21 amperes. So, the parallel volts would then be 0.21 ampere times 30 ohms, which gives you 6.3 volts. Okay, the last example for this lesson. In the electrical circuit shown below, the battery has an EMF of 6 volts and an internal resistance of 1 ohm. The total external resistance of the circuit is 9 ohms. Calculate the current in R1 when the switch is closed. Okay, we want the total current. That is the current flowing through R1. So we need the total resistance and we need the total volts. The total resistance is the resistance external plus the resistance internal. And the volts is the EMF value that they give you. So the resistance external they give you in the question, 9 ohms, plus 1 ohm internal resistance, and the EMF they give you in the question, 6 volts. So you substitute the values and you calculate IT, which is then 6 volts divided by 10 ohms to give you the total current as 0.6 amperes. Now there's a second part, which says the power dissipated in resistor R1 is 1.8 watts. The resistance of resistor R3 is 4 times that of the resistor R2. Calculate the resistance of resistor R2. Okay, now you go with what you have. You have a set of formula equations in your formula sheet. So there you get P is equal to I squared times R, power. We have the power. It's 1.8 watts. We also have the current through R1, which we just calculated, 0.6 amperes. So you can get the resistance for R1. So let's calculate the resistance for R1. You have 1.8 watts divided by 0.6 amperes squared. That gives you 5 ohms. Make sure that you punch it correctly in your calculator. Now you can get R parallel. And you need that because you want to end up with R2. So, R external is 9 ohms. They give it to you in the question. That is equal to R series, which we just calculated, R1. And we want R parallel. So let's substitute our values. R external is 9 ohms given in the question. 5 ohms we just calculated the value for R1. Now we can get R parallel, which is then 4 ohms. Now we want R2. 1 over R parallel is 1 over R2 plus 1 over R3. Remember now, R3 is equal to 4 R2. So let's substitute that. and we substitute R parallel, which is 4 ohms, as we calculated on the previous slide. That brings us to 1 over 4 is equal to 1 over R2 plus 1 over 4 R2. Now we add them just as if R2 was X. So 4 R2 needs to be added, the R2 needs to be converted also to 4 R2. So you times it with 4 to get to 4 R2, and what you do at the bottom, you must do at the top. 1 times 4 is 4. So 4 plus 1 gives you 5 over 4 R2. But we want R2, so now we switch our fractions top to bottom. That gives you 4 over 1 is equal to 4 R2 over 5. Now we multiply the 5 that way, that gives you 20 is equal to 4 R2. And then you get to R2, which is 5 ohms. This is a bit more challenging maths, but so you can go through it slowly again. Thank you.